Question 2a. Complete the table to give the formula and acid-base behavior of some oxides of the period 3 elements. Okay, so for the oxide, okay, aluminum will form Al2O3, silicon will form SiO2, phosphorus will form P4O10, better you put P4O10. Okay, and acid-base behavior, we know that after this aluminum oxide, okay, they are all acidic oxide. Okay, sodium oxide is basic, aluminum oxide is amphoteric, silicon, phosphorus and sulfur oxide, they are all acidics. Okay, part B, 1. Beryllium hydroxide is an amphoteric compound that shows similar chemical reactions with aluminum oxide. Okay, state the meaning of amphoteric. Very easy. The species that reacts with both acid and base. Okay, part 2. Write an ionic equations for the reaction between this magnesium hydroxide with the HCl. Okay, we just need to put the actual species that reacts. Hydroxide from this magnesium hydroxide and the H plus from the acid. So therefore is hydroxide with H plus from H2O. Okay, part 3. The two methods of preparing strontium hydroxide. Okay, so first method, reaction 1, strontium add to water forms strontium hydroxide. This is the equation. Strontium with water forms strontium hydroxide is produced gas. So you see fizzing or effervescence. Okay, when we put strontium oxide in water and it's formed hydroxide, it's just this compound. It's from this compound, no gas. That's why reaction 1, you see gas formation, effervescence. Reaction 2, you just see the solid dissolves. Okay, part 4. State how the solubility of group 2 hydroxide changed down the group. We know that when down the group 2 hydroxides, okay, solubility increases. Part C, we have this Na2O2, sodium peroxide, react with CO2. Okay, this is the equation. Partial pressure of CO2 given in the this 0.5 dm cube sample. Okay, pressure is 5.37 kilopascal. Okay, and 20 degrees C. So from here, you know, you should know that, okay, must use the combined gas law. And make sure you convert all this to the standard unit. Okay, so is PV equal to nRT because it's asked to calculate mole. Therefore, is the N equal to PV over RT. So pressure is in Pascal times 1000 here. And the volume must be in meter cube, dm cube to meter cube must times 10 power negative 3 over the gas constant 8.31. Okay, this one make sure is Kelvin. So it's 273 plus 20. So you get this mole, the mole of CO2. Calculate the mass of Na2O2 that will react fully with CO2, which you calculate in part 1. Very easy, we know that this one is 1:1 mole ratio. The moles of CO2 must same as the moles of sodium peroxide. Okay, therefore use the moles that calculated in part 1 times the molar mass of Na2O2, 70, which is 78. So you get 0.0858 gram. Okay, so for part 3, draw the dot cross structure for or diagram for this peroxide ion. Okay, already give you a hint. It has single covalent bond between the two oxygen. Therefore, you just need to put a pair of electrons between. And you have to know how many outer electrons you need to show. Outer electrons only, okay, oxygens each will contribute 6 electrons, total is 12. Okay, but this is not the total number because peroxide is 2 negative, it must gain 2 electrons from outside. So in your dot cross diagram, you must show 14 electrons. Okay, so put a pair of electrons in between oxygen and you complete with the remaining electrons of oxygen. Okay, means 1, 2, 3, 4, 5. Okay, and this one 1, 2, 3, 4, 5. Okay, 1 electron is being shared. Okay, and you have to draw 2 cross, okay, on the oxygen's atom, 1 cross each. So this cross is showing that these electrons is from other species. Okay, so there's a dot cross for this, and that's all for this question. Thank you.